To find the mass of a copper of length 5 km, we need to multiply the density of the copper by the volume of the cable. And the volume of the cable is given by the cross-sectional area of the cable multiplied by the length. And it's given the questions that the length is 5 km and the cross-sectional area is 3 times 10 to the power 4 meters square. I'm sorry, it's 10 to the power minus 4. And the density of the cable is given as 8,900 kilogram per meter cube. So with this information, we can now calculate the mass of the copper cable. So it's given by 5,000 multiplied by 3 times 10 to the power minus 4 multiplied by 8900, and this gives 4,050 kilogram. Alright, let's look at the next part of the questions. Alright, so here we need to calculate the minimum number of towers needed between the grid and the factory to support the copper wire. So we have a factory here, the wire and the tower, and now our task is to find the number of towers needed to support the cable. And so first thing first, we need to find the weight of the cable itself, which is given by mg, since we have already gotten m in the previous part of the questions, and g is 10 meter per second square. So this is nothing more than 40,500 Newton. Alright, and the number of tower is simply given by the weight of the cable divided by F number, and it's given the question that the F number is 9,000, so this is simply given by this expression. And then by doing a bit of calculation, we arrive at 4.5. And since the question wants us to find the minimum number, and that cannot be a half tower, so we round this number up to 5. So altogether, we need 5 towers to support the cable. Alright, let's look at part B. So in part B, the situation is a bit different. And now we are using aluminum instead of copper. And the current that carries by the aluminum cable is 500 ampere. So first part, we need to calculate the potential difference between the grid and the factory. So first of all, to solve this kind of questions, let me represent the potential difference by delta V. Is given by I, the current in the cable, multiplied by the resistance of the cable, which is actually the power drop across the cable. And so what is the resistance? So the resistance is given by, as we can read from the table, the resistance of 1 kilometer of aluminum is 0.075 ohm. So this is the value for 1 kilometer, and now we have 5 kilometer of cable, so we need to multiply it by 5. So altogether we have 0.375 ohm. Alright, so with this information, now we can calculate the value for delta V. So it's pretty straightforward. It's 500 multiplied by 0.375, and this gives 187.5 volt. Alright, so for part 2 we need to calculate the power loss in the cable. So this power loss, to calculate the power loss, we just use this equation, which is I squared multiplied by R, where I is just the current that carries by the cable, and R again is the resistance of the cable. So since we have already got this information in the previous part of the questions, so we just substitute it, and we get 93.75 kilowatt. So it's actually quite a lot of power get lost in the cable. And then for the third part, we need to calculate the cost each day of this power loss. And it's given that 1 kilowatt hour costs us 22 cents. So first of all, we need to calculate the total usage, which is actually given by power multiplied by 24 hours, because we need to calculate the cost for the whole day, which consists of 24 hours, and this gives 2250 kilowatt hour. Alright, and to calculate the cost is just going to be this number here multiplied by 0.22, and then this is equals to $495. Alright, let's look at part C. Using data from the table, explain why aluminum is a more suitable material than copper for the cable. So to answer this question, first of all, we need to know the idea, the logic behind the questions. So when we build a power grid, what is the most important consideration that we need to take into account? So for the construction, of course, number of tower is the major concern. Alright, so and then let's look at the table. So the parameters that determine the number of towers that we need to support the cable is the F number and the density of the cable, since we know that the cross-sectional area of the cable are the same. This is the density, and then let's compare the F number of the aluminium and the copper. So for aluminium, the F number is 6000 and copper is 9000. So from here we know that copper apparently has a higher F number, but the ratio of them is only 2/3. And then as for the density, aluminium is actually much lighter, in the sense that it's less dense than copper. It's only 2700 kilogram per meter cube. As for copper, is 8900 kilogram per meter cube. And the ratio of this is actually less than 1/3, less approximate to 1/3. So since we know that the number of towers, let's represent it by n. This n number is directly proportional to rho and inversely proportional to F. So in the case of aluminium, we just need to take the ratio between the aluminium and copper in order to compare the number of towers that we need for both cases. So the number of aluminium versus the number of copper, will be given by approximately this this number here divided by this. Yeah, since we know this relationship, so it's 1/3 divided by 2/3, so it's equals to half. So from here we can make a conclusion that if we are using aluminium as our uh, as our cable, the material for the cable, then the number of tower that we need to build is only half of the number that we need if we use copper as the material for the cable. So that's the reason why aluminium is more suitable. And second part, steel is an unsuitable material for the cable. And if we look at the table, we can see that the resistance of steel is 210 ohm per kilometer, and it is much higher than aluminium and copper. So based on this, we know that is the resistance is too high, and that's the reason why it's unsuitable. Alright, that's all.